Okay, let's look at this problem involving a rational function with a quadratic on top and a linear function on bottom. So first thing I'm going to try to do is factor the top and bottom. So I'm going to try to factor this guy here. Now a lot of times what you'll see is this does not factor, and I think that's going to be the case here. I could pull a -1 out, and this could become x squared minus 2x minus 5. And then I know there are no two numbers that multiply to -5 that add to -2, because the only possible factors of -5 are -5 and 1 and 5 and -1, and neither of those add to -2. So that does not factor. So if I'm looking at this function, I know nothing's going to cancel out, so right away I know there are going to be no holes. Because holes occur when you cancel something out from the top and bottom. Well, if the top doesn't cancel, or doesn't factor, pardon me, there's going to be nothing to cancel with on the bottom. So I know the bottom here, where x can't be -1, if I think of my domain, x can't be -1, because if I put in -1, I get 0 on the bottom, which is bad. So I know this has to be a vertical asymptote. So this has a vertical asymptote at x equal -1. So if I start to build my graph, I'll just kind of sketch it down here. I know at -1, this is going to have a vertical asymptote. Now, when we go on to horizontal asymptotes or slant oblique asymptotes, this one actually has a slant asymptote. The reason it does is because when the degree of the top, this is 2, is bigger than the bottom, then we have a slant asymptote. Now, slant asymptotes are pretty tough to find. The way we do it is we use polynomial long division. So what I'll do is I'll take the x plus 1 and I will divide it into -x squared plus 2x plus 5. This should give me some kind of line, and when I say line or slant asymptote, it should be something like y equals mx plus b. So once I get to an mx plus b, I can pretty much stop. So what I'll do is I'll look at the first term in each one, and I will divide it. So I'll do -x squared divided by x. There are lots of ways to do polynomial long division. However you like to do it is fine. So -x squared divided by x is -x. So I'll put that up top. I will then multiply that to both things out front. So that gives me -x squared minus x. And then the big thing here is we want to subtract. So when we subtract, we're just going to change the sign. So these will both become positive. So -x squared plus x squared will go away. And now 2x plus x gives me 3x. And I'll bring down the 5. So now I'm going to do a very similar thing. I'm going to take the first term in my new polynomial and divide it by this x. So I'm going to do 3x divided by x, which is 3. So plus 3. And I can stop here because here's my mx plus b. So my slant asymptote is going to be -x plus 3. So if I plot that over here, here's 1, 2, 3, there's 1 here. So there's a y-intercept of 3, down 1 over 1 leads me up here. So there is my slant asymptote. Now obviously the graph says just pick any 2 points on each piece of the graph. So there's typically going to be one piece on this side and one piece on this side of the x equal -1, which is our vertical asymptote. So you could just pick any point you want. So maybe I pick a point of x equal -2 and figure out what that is. And then I pick another point, maybe x equals 0 would be a pretty easy one for the y-intercept. If I do 0, I know I get a y of 5. So that would be somewhere up here. So my one point on my graph I know is going to be that point here. And then if I plug in -2, I'll get, let's see, I get -4 minus 4, which is -8 plus 5, which is -3. -3 divided by -1 is positive 3. So if I go -2, positive 3, that's a point up here. And then I know that my graph is going to kind of tug along this vertical asymptote and approach this horizontal asymptote. And then I know the same thing, it's going to kind of be vertical here. It's got to go through that point, and then it's going to flatten out. So it looks something like this. But I'm pretty confident if you get these 2 points and you have your vertical and your slant asymptote, once you plot the curve, hopefully it looks better than mine. It's not very good, but it will give you the graph you're looking for.